So right now in our model, we have people presenting for care, but it's kind of like the Hotel California of care. They never get out again. They never get home. This is only a very incomplete representation of the impacts of healthcare. So we're going to want to put in a representation of flow in the clinic. Are we okay with that? Okay, so fasten your seatbelts. You may even want to save a copy of this model along if you want to study it in its current form, but we're going where you've never gone before. Okay? Great. Okay, now I would like you to go to the clinic. There was a really good question about going to, like, why is it we determine the nearest clinic up front? There's really no good reason for that. Showen pointed out, we really don't have to do this. We could, on the fly, have them go to the nearest clinic. How would I change it if I wanted to do this? This gets to Roberto's question about resilience. What's the problem? So, doing it up front, what's an advantage of doing it up front? Well, those of you worried about performance, give me a slight gain for saying what's the nearest clinic once ahead of time. Boom, done. And done with it. But really, and this is a good lesson about performance issues, there's so much mechanism in AnyLogic to do the work it needs to do, to chunk through the event list, to do scheduling, etc., and to do the visualization, that probably that's in the noise. I mean, it's probably infinitesimal. It's not a serious bottleneck. But there's another issue about determining the clinic ahead of time that is a serious issue, and that troubles me as a software engineer. And what is that? What's the problem with determining the clinic up front and then just sticking to that clinic? It is rigid. It is fragile. Let me hit each of those. Why is it rigid? Yeah, if there were a new clinic introduced, if we wanted to roll out clinics over time based on care-seeking behavior, we'd introduce a new clinic, but no one would come to it, right? Because they're all set to go to the initial clinic as they determined at the beginning of the model. True or not? True. So it's rigid in that sense. I would say it's also fragile. Why do I say it's fragile? It's fragile because if one of those clinics were to close its doors, or for that matter to relocate, suddenly people would not be going, well, actually not to relocate, but to close its doors. Suddenly the people would be going to a non-existent clinic, and bad things would happen. It would probably distress you. Things like null reference exceptions. And I don't like my students being subjected to the vagaries of happenstance. And so if we want a robust model, an adaptive model, a model that's self-adjusting with new clinics as they come in or clinics as they disappear, we should make that dynamic. In other words, rather than determining it once at the beginning of time and sticking with the program for which clinic we present, instead we can determine it dynamically while the model's running. Can we not? At the point of care seeking, it's the equivalent of looking it up in the yellow pages. What's the nearest clinic? Something like that. What do you think? Should we do that? How would I do that? How would I do that? Okay, actually it's a great idea, but this is a case where actually we're going to eliminate a parameter. Yes?
What about changing the capacity of each clinic?
Okay, we could do that, but because I want to finish this example, we're not going to have time to do that. I just want to right now, maybe this afternoon we can talk about that a bit, but let's say right now we have the nearest clinic being computed when? At the entry to the state chart, right? And then where is it used? How many places is it used? Let me show you a neat little feature of AnyLogic, a feature that I use very frequently. Okay, and that is use search and replace. There's actually a little thing up here. There it is. See this? Search replace. Here you go.
and you can search for nearest clinic. Okay? And where you'll find is, okay, it's referred to at 3 places. One is here, and one is here. This is where it's used. The other place is where it's declared, where it's first defined. This guy here. Okay, so it's actually only used one place. So all we have to do to adopt Xiaowen's great idea is take this calculation, get nearest agent, and we need to go instead to what? To where it's used, and just substitute that. And now we're done. Okay, so backing up. Okay, let me make sure I've undone it. Yeah, okay, here. Okay, so all I did is I went to this place. Let me get rid of this cruft now. Okay, so I went here. Okay, and here's this assignment to nearest clinic. We determine it coming into the state chart. And from then on, we're going to use this nearest clinic, right? That's the clinic to which we will present. And that's fragile, and it is rigid. It doesn't let us to exploit a new clinic, and it will end us up at the same clinic even if it closes the doors. We'll be in bad shape. We'll go to a clinic that doesn't exist. So what we will do is we'll call this thing that determines the nearest clinic. See that? Do you see that? Okay, and I will get rid of that little line then, and I will go here where it says move to the nearest clinic, and I'll substitute instead what? That exact thing. So what's going on here? When we go to this place, we're going to first look up what? The nearest clinic, and then move to it. So we're going to say, okay, where am I going to go? Look up, oh, the nearest one is here. Or I look, the nearest one is here. I'm going to go to that. It's kind of live, it's dynamic. It's at the time that I need it. It's at that point that I determine what's the nearest clinic. So there's no risk that, I have some plan in place to always go to the clinic of Dr. G. McDonald, which is a fine clinic indeed. I don't have this rigid idea in place, and find that it doesn't work. Instead, at the time, I determine what's the nearest clinic, and if the clinic of Dr. G. McDonald is closed its shop, then I'll find the new nearest one, the one that's nearest right now. If, on the other hand, a nearer one is open, if Dr. Sternberg has opened a clinic nearby, even closer than that of G. McDonald, which would seem to be the case, I could present for care with him. So I'm going to first determine the nearest clinic at this time and immediately go to it. So it's on the fly, it's dynamic, it's just in time. We determine what's the clinic and we go to that. So there's no risk that we have some pre-examined plan that's now going to break. Does that make sense? That's all we need to do, and now we can, of course, delete the nearest clinic variable. We don't need this variable anymore because we just determine it on the fly. Does that make sense? Okay, question.
I was going to say that doesn't actually change the get nearest clinic variable value.
So now we can eliminate that variable, and now we're done. So first, what this means is first we get this nearest clinic, we find the clinic, and then we move to it. What information does get nearest agent need? It needs a list of all the clinics. Having found the nearest such clinic and gotten it, that is used as the information that move to needs to do its job. Does that make sense? Okay. Great. Okay, but that was just a sort of a comment, but it has to do with resilience. It has to do with robustness of a system. This idea that you do things adaptively just in time. So if changes have occurred, it doesn't throw all your plans awry. The best laid plans of mice and men
you know, don't have to go out the window. You make those plans at the time using the latest information. And this is one component of resilience. There's another component Dylan will talk about sort of auto configuration he may mention, which is also part of it. You configure things as you need to right now based on the situation. Okay? Okay, so, but the grand